Hello everyone, welcome to our channel. Last video we discussed about the rational numbers and properties. In this video we will discuss about the additive, inverse, additive identity, properties of multiplication of rational numbers in the closure property, commutative property, associative property, multiplicative inverse, multiplicative identity. Let's see one by one. First one is additive identity. The additive identity for a rational number is 0. So let's see few examples. 0 plus minus 3 by 5 is minus 3 by 5. Second example is 0 plus 7 by 8 is 7 by 8. And 1 by 2 plus 0 is 1 by 2. 0 minus 9 by 5 is minus 9 by 5. To the 0, if I add any rational numbers, again we will get the same rational numbers. So 0 is the additive identity. Let's see the second one, additive inverse. What is additive inverse? The negative of a rational number is called its additive inverse. What does that mean? For if I take 3 by 5, write the negative of this, minus 3 by 5. Next, see the second one, minus 6 by 5. Make it positive 6 by 5. Then 1 by 2 minus 1 by 2. Just here you have to change the sign. Write the rational number is as it is. Positive become negative, negative become positive. Okay. Then we'll see the next one concept is closure property. What is closure property? Take any two rational numbers. I'm considering A by B and C by D. Multiplication of any two rational numbers, again we'll get a rational number. That rational numbers we are taking E by F. Multiplication A by B into C by D equal to E by F. Okay. Let's see whether we'll get a rational number or not. So here I'll consider the few examples. First one is 1 by 2 and I'll consider 3 by 4. Let's multiply 1 by 2 into 3 by 4. So numerator with numerator, denominator with denominator multiplication we should do. 1 into 3 is 3, 2 4s are 8. So see, 3 by 8 is also a rational number. Second example is 3 by 6 and 1 by 4. So let's multiply these two. 3 by 6 into 1 by 4. You can see any cancellation in between these two rational numbers with 3 and 4, 1 and 6. No, there is no cancellation. Next, we should do multiplication numerator with numerator, denominator with denominator. 3 1s are 3, 6 4s are 24. Okay. 3 by 24 is also a rational number. The closure property is also in multiplication. Next property is commutative property. Here also we should consider the two rational numbers. Those two rational numbers are considered as A by B and C by D. Okay. The closure property formula is A by B into C by D in right hand side, C by D into A by B. So if LHS is equal to RHS, the commutative property is holds good in rational numbers. Let us take few examples. 1 by 2 and I'll take 3 by 4. So A by B represent 1 by 2, C by D represent 3 by 4. Let's substitute 1 by 2 into 3 by 4 and in right hand side 3 by 4 into 1 by 2. Let's multiply numerator with numerator, denominator with denominator. 3 by 8. Here 3 by 8. So LHS is equal to RHS. So let us take another example. Example 2. 3 by 5 and 5 by 6. 3 by 5 into 5 by 6. On right hand side, 5 by 6 into 3 by 5. So you can see in the left hand side, 5 and 5 get cancelled. 3 ones are, 3 twos are. So in right hand side, 5 ones are, 5 ones are, 3 ones are, 3 twos are. Now 1 into 1 is 1, 1 twos are 2. Here also in right hand side, 1 into 1 is 1, 2 ones are 2. So LHS is equal to RHS. Commutative property is holds good in multiplication of any two rational numbers. This is the formula to check whether it is equal or not. The next property is associative property. For associative property, we should consider the three rational numbers. Those rational numbers is in the form of A by B, C by D, and E by F. Okay. The formula of associative property is E by B into C by D into E by F. In right hand side, A by B into C by D into E by F. Next, grouping these two. First, you can group first two rational numbers and last two rational numbers. So, we should check whether we'll get LHS is equal to RHS. So, next is consider the three rational numbers 1 by 2, 3 by 4 and 5 by 2. So, 1 by 2 into 3 by 4, put a bracket, into 5 by 2. A by B is 1 by 2 into 3 by 4 into 5 by 2. First, we have to simplify the bracket terms. So, any cancellation in numerator and denominator or cross cancellations, if it is not there, you can multiply numerator with numerator, denominator with denominator. 3 by 8 will get into 5 by 12. 1 by 2 into 3 5s are 15, 4 2s are 8. Next, again here also rational number multiplication. 3 5s are 15, 8 2s are 16. In right hand side, 15 ones are 15, 2 8s are 16. Now we are getting LHS is equal to RHS. Associative property is holds good for any three rational numbers, that is in multiplication. Okay. Next is multiplicative identity. Multiplicative identity for the rational number is 1. 1 into 3 by 5. We'll get again 3 by 5. 1 into minus 1 by 2. Again we'll get minus 1 by 2. So you can see few examples. We are getting the same rational numbers. 1 into minus 20 by 47 minus 20 by 47. 7. So here you can see we are getting the same rational numbers. With the 1, if you multiply any rational numbers, we'll get the same rational numbers. That's why 1 is the multiplicative identity. Multiplicative identity for rational number is 1. Our next concept is multiplicative inverse. Let's see what is multiplicative inverse. The reciprocal of a rational number is called multiplicative inverse. For example, I'll take minus 5 by 8. The reciprocal of the rational number. Reciprocal means you will make it 8 by minus 5. Okay, we are not changing any sign. Okay, the reciprocal of rational number is multiplicative inverse. The second example you can take 3 by 5. The reciprocal is 5 by 3. We are not changing any sign, just reciprocal of the given numbers. Minus 1 by 2, that is equal to 2 by minus 1. Okay, this is the examples for the multiplicative inverse. The reciprocal of rational number is called its multiplicative inverse. Okay, in this video we discussed additive inverse, additive identity, closure property, commutative property, associative, multiplicative inverse, multiplicative identity. 0 is the additive identity, and the additive inverse you have to change the negative signs of the rational numbers. Closure property A into A by B into C by D equal to E by F. Closure property formula. Commutative property, associative property, multiplicative identity, multiplicative inverse. So in next video, we'll discuss a distributive property of multiplication over additions. Thank you everyone.